Today we are moving into the next section of operating monomials and polynomials. Today we are still in the world of monomials, but this time we are raising a power to a power. So there's two different methods to do this. So we are first going to look at the steps on the left. So we're going to practice the method that we would use on this side, and then I'll show you what we would do for the other side here. So step one, what we're going to do, it's called draw blanks. So if we look at this first one here, there's a 2 out here. And so what that means is I need to draw 2 blanks for this question here. And I'm going to put x to the 4th on both of those blanks. So I have x to the 4th and another x to the 4th. So now I use my multiplication rules. Multiplication rules that we learned yesterday. So what the rules are is we just count the exponents. So if there's 4 of them here and 4 of them here, that makes a total of 8 of them. So let's do the same thing again. Step 1, we expand. We're going to draw blanks. We're going to draw 3 of them because it's a 3 on the outside. On these blanks, we're going to write what was inside parentheses. So this gives me a total, 5 and 5 and 5 gives me a total of 15. So this would be a to the 15. So let's look at a couple more like this. Do the same thing with number 3. So on number 3, we have a 4th power. So we're going to draw 4 blanks. On those blanks, we're going to write down what we had inside the parentheses. So it's 2a5, b3. 2a5, b3, 2a5, b3, 2a5, b3. So now the rules for multiplying means we multiply these coefficients. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then we count all of our letters. 5a's plus 5a's plus 5a's plus 5a's. This is a total of a to the 20th. Then we count all of our b's. 3b's, 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 3b's is b to the 12th. Okay? Same idea, one more time. This 2 means I need 2 blanks of what was inside. So this one here is negative 3x squared, y to the 5th. Negative 3x squared, y to the 5th. Then I need 3 blanks of this information. 4, x to the 6th, y to the 4th. 4, x to the 6th, y to the 4th. 4, x to the 6th, y to the 4th. So if we multiply all of our coefficients, that's negative 3 times negative 3, which is 9, times 4, times 4, times 4. That's the number 576. Then we go through, we count all of these x's. 2 plus 2 is 4, plus 6 is 10, plus 6 is 16, plus 6 is 22. So that's x to the 22. Last but not least, we collect all of our y's. 5y's and 5y's is 10. 4 is 14, 18, 22. Weird. Same number, unless I counted wrong. Okay? So that's what we do when there's a power on the outside. We draw blanks, and then we use our multiplication rules that you guys are good at. So let's go ahead and flip over to this page here. Okay, simplify by expanding. So on the next page, if you flip to the back, the left side says that we're going to simplify using the expanding method. That means we draw 3 blanks, and we put x squared on each of those blanks. Count your exponents. There's a total. 2 plus 2 is 4, plus 2 is 6. That's x to the 6th. So go ahead and try these left side. You're going to do numbers 2, 3, 4, and 5. Take a minute, try numbers 2 through 5. All right, so now let's flip back over to the front. So the first method, the one that I prefer, is called expanding because it makes the most sense. We're expanding it and we see what happens. But what happened a few years ago is the STAR test said, hey, let's throw a fraction on the outside, and that's what made it much more difficult because we can't expand and draw blanks if that power on the outside is a fraction. So we have to use the other method on the right side of this page. So let's look at number 5 on the right side. So on number 5, you could draw blanks. That's a whole number, it's a 2. So you could draw 2 blanks, and then you could use your multiply rules. What the other method, though, is we take this 2 and we distribute it to each of these pieces. So this says 4 to the 2, x4 to the 2, y10 to the 2. Okay, and that's going to leave me 4 to the second power is the number 16. It's not 8. 4 to the second power, it's an exponent, so that's like 4 times 4. And then these, we just distribute, just multiply. This one, 4 times 2 is 8. 10 times 2 is 20. Okay, so we can distribute, but the whole number, the coefficient, you could plug in the calculator, 4 to the second power, and that's how you get that coefficient. So let's try that same thing again. So in number 6, if you have a power on the outside, you can give it to each piece. So this here is the number 36, and we're giving it a 1/2. Then we have x to the 12th, and we're giving that 1/2. Then we have y to the 18th, and we're giving that a 1/2. The whole number, plug that in the calculator, 36 raised to the 1/2. So you'll type in 36. There's a button that looks like that. We raise it to the control divide 1/2. 36 raised to the 1/2 is the number 6. So then these, you just multiply. 1/2 of 12 is 6. 1/2 of 18 is 9. Let's cross out number 7, because I'd prefer using the expanding method for number 7. So you really only have to use this distributing method when this is a fraction on the outside of your monomial. So go ahead and flip to the back. And now you're going to try this right side. If you're comfortable using the expanding method, that's fine. You can practice the expanding method. If you're comfortable with distributing, you can distribute to each number. Just make sure that your coefficient 4 gets raised to the 5th power. Not times, but raised to the 5th power. For number 11, you have to use the method where you just plug it in the calculator, 16 raised to the 1/2, and see what you would get. So that is everything for today. So today you learned that you can either draw blanks. If it's a whole number, I can just draw blanks, and I can write what was inside on each of those blanks. If it's a fraction, we can't draw blanks. We have to distribute that fraction to each piece of your monomial. Very easy.